This is part A of the probability distribution graph Groovy Google Sheet activity. In part A, we're going to be working with continuous microdata. So continuous means that there's an infinite number of values, including all the decimals in between. And microdata means it's a list of data, so the data has not already been put into a frequency table. Now, because the data is continuous, your data has to be put into ranges like this. So 130 to 140, 140 to 150, etc. And you have to use either the square brackets or the round brackets to indicate if you have a number like 140, which is on the edge of two, or on the boundary of two intervals, which one is it going to go into? So the square bracket means it goes into that range right here, and the open bracket means this is everything up to but not including 140. So to make a probability distribution graph, it's basically you're making a histogram, but the y scale, instead of being absolute frequency, it's relative frequency. And these are all graphs that you've already made in the histogram Google Sheet activity, so this shouldn't be a lot that's new. But we're going to go over it again. So we're going to start with the continuous microdata sheet, and this data shows the heights in centimeters of a sample of students at Sir William Mulock. Now what you can't do is just go and make a histogram by highlighting the data and inserting a chart and making a histogram, because that will make the y-axis to be the absolute frequencies and not the relative frequencies. So what we have to do is make a frequency table ourselves and then change the absolute frequencies to relative frequencies. So these are the intervals we're going to use. So in cell C1, we're going to type in buckets. And your buckets is basically the same as your intervals. And then starting in cell C2, what we're going to do is type in the upper boundary of each interval. So our upper boundary is 140, 150, 160, 170. However, because we're not including 140, what we're actually going to do is instead type in 139. If this was the square bracket on the right side, then you could type in 140, 150, 160. But since it is the round bracket and we don't actually want to include 140, then for the upper boundary of each interval you would do 139, 149. So that's going to be showing everything that's basically between 130 to 139. Now if your data had decimals and there was something like 139.5, then you could just make this 139.9 or 139.99. or 139.999. But because we don't have decimals, we can just type this in as 139. And to make a pattern, you could just type in the first two, 149, and then highlight these two and copy it, Control C. And then what we're going to do is drag this down as far as we need to, which is to cell C9. Now later on we're going to be changing these to be the actual interval so it looks like these, but to start in Google Sheets you can't type in what the buckets are, you can only type in what the upper bucket is. Now the other thing too is that you should consider is that if you actually have a number that's 210, you may not want there to be another interval. So sometimes people may want to have a closed bracket here. It's okay for the last interval to have a closed bracket on both sides, but it's up to you. You may want another category. So if you had the number 210, you might want another category that says 210 to 220, but it's not necessary. In cell D1, we're going to type in frequency. And what we're going to do is let this calculate the frequencies for us, just like we did in the histograms. And the formula for doing that is right here. So we're going to type in equals frequency. And you can type in A2 to A111, or you can just highlight the data. And even a faster way is to click on A2 and then Control Shift or Command Shift if you have a Mac, and then press the down arrow key and it'll highlight all of it. Then you're going to type in a comma, and then you're going to type in what your upper bucket boundaries are. So C2 to C9, you can type in C2 to C9, or you can just highlight it. And you can press enter or close the bracket. If you press enter without closing the bracket, it'll close the bracket for you. And what it does is it puts in the frequencies for everything. You don't even have to do an autofill. It puts in all of the frequencies. Now this here should read 0, and all that's really telling you is that there is no number higher than 2009. If there was a number here, then you would have to include more buckets, and you'd have to, maybe you had the wrong maximum, so you could always put these into, sort them into in ascending order and take a look at what the highest number actually is. Now, in cell D11, we're going to add up all the frequencies. So we're going to type in equals sum, and we're going to add up all the frequencies, and we need to do this so that we can make percentages. In cell E11, we're going to type in heights, and now this is where we're going to type in what the actual buckets are. So starting in E2, we're going to type in the intervals with the proper brackets. So the first bracket, so that was the upper boundary, the first bracket was including, so a square bracket 130 to 140, but not including 140, so that's an open bracket. Now unfortunately there's no way to fill these down, so you have to actually type them in. So it's including 140 and up to, but not including 150. So that's a round bracket there. Square bracket, including 150, up to, but not including 160, close it with a round bracket. Square bracket, 160, up to and including 170, round bracket, and keep going. 170 up to but not including 180, square bracket 180 to 190, open bracket, square bracket 190 to 200, open round bracket, and square bracket 200 to 210, round bracket. So that's what's going to end up going on our x-axis. Now in F1, we're going to type in the probability. So before you just called this relative frequency, probability is the same as relative frequency. And starting in F2, we're now going to turn all of these frequencies into percentages. So we're going to type in, or click equals, after equals, click the D2 cell. So it's 4. And then the divided by symbol, 4 out of 110, so click on D11. And it needs to be a absolute frequency, or an absolute reference, so you need the dollar signs before the D and before the 11. So you have to press your F4 or your function F4, whatever that command is on your computer. If you can't get it, you can just type in a dollar sign before the D and a dollar sign before the 11. And when you click enter, so that is now showing that that absolute frequency of 4 has a relative frequency or probability of approximately 0.036. And then you can fill that down to F9. And by making that an absolute reference, when you fill down, the frequencies change as the cells go down, but the total always stays at D11. So these are the two that we're going to be making a graph of now. So here is just reminding you that relative frequencies from before is the same as probability, because probability you're taking the favorable number of outcomes, which is just your frequency, and dividing it by the total number of outcomes, which is just the sum of all your frequencies. Now, as soon as you turn it into aggregate data, which means we have a frequency table, you can no longer make a histogram. You have to make what is called an area chart. And we're going to make a stepped area chart. This gives us a relative histogram, and a relative histogram is the same as a probability distribution graph. So rather than saying that's approximately 3.6% of students are between a height of 130 to 140%, or sorry, 130 to 240 centimeters. Now it's just saying if we were to pick a student at random, there is a approximately 3.6% chance, or the probability is approximately 0.036, that the student would be in the height of 130 to 140. So what we're going to do is we're going to highlight this data in columns E and F, and we're going to insert an area chart, and we want a stacked area chart, sorry, a stepped, not stacked, stepped area chart. So under chart type, you're going to pick area chart, and make sure you pick the right one. That's the stacked. This is the stepped. We want the stepped. Very important. It's the stepped that we want. Right there. And you could go back about how to format it using in the histograms worksheet, but pretty much the only thing you're going to have to change is we're just going to darken this up a bit. So under series, we're just going to change that to 100, and it just darkens it up a bit. So there is your probability distribution graph. If your data starts in microdata, you have to change it to aggregate data and then make the area chart. And in your first summative with the game, your experimental data is going to look like this. So this is how you're going to have to make the graph using this method. Now, since a continuous variable has an infinite number of possible outcomes, that's the whole point of this being continuous, is there's an infinite number of possible outcomes. It is impossible to determine the probability of obtaining a particular outcome. So the probability of obtaining a particular outcome is equal to 0 for any value of x, because the whole idea is what's the probability that a person is exactly 140 centimeters? Well, since there's an infinite number of possibilities, the total number of outcomes, this is infinite, so it doesn't matter what goes on the top. If the bottom is basically infinite, it's going to make the probability equal to 0. So we almost always talk about this probability when it's continuous data as being ranges. So we wouldn't ask what's the probability of a person being 150 centimeters, because even though you could count how many people here are 150 centimeters, chances are they're actually not 150 centimeters. It's been rounded to 150 centimeters. So you can just take a look at these ranges to find out what's the probability that a person is between 150 to 160 centimeters. Well, you can see that in cell F4, probability of being between 150 to 160, that would be equal to 0.136 approximately. And the probability of being between 140 to 170, well, what we would do is it would be these three things, and you can add them together. And if you look down here, it gives you the sum. So that is approximately 0.427 or 473, I guess, approximately. And the probability of being over 2 meters tall, that would be this right here, and that would be approximately 0.055.